Right. Good morning, my dear students. The last session, we have completed step 3, that is this slide, where we have come across the calculation of beam end moments. So, just to recall, we are solving for uh, a frame by using cantilever method, which is an approximate method. So the second method that you are studying in this unit. So from that, we have come to step 3 calculation. So beam end moments are being calculated in the last session. Okay. So now we will see how to calculate the next quantity when you know beam end moments. Means these quantities. So these are the beam end moments that are being calculated in the last session. So now let us see what next. The step 4, if you see, the column end moments can be calculated only after knowing beam end moments. Okay, so let us see how to calculate column end moments. That is step 4. Okay, so column end moments can be calculated by using moment equilibrium of joints. So you have to select each joint of the frame, then apply sigma m is equal to 0 for that particular joint. So if you see this equation, so this is joint A that I have taken. So sum of all moments at joint A is equal to 0. So let us see what are all at joint A. So this is joint A. There is a beam and there is a column. So beam AB and column AH are joined at A. So the joint A has got only two members. So out of which you know the moment MAB, and now you are calculating MAH. Okay, so that is the calculation that is to be done. So this is the expansion of this equation, right? So moment MAB and MAH, total moment should be 0. So when you say moment, there will be sign convention that is to be followed. So plus is for clockwise moments, minus is for anti-clockwise moments that we are following. So as AB has got anti-clockwise moment, so this is negative moment, and as a default case, I have taken positive because I don't know the direction of MAH and the value. Value and direction both are unknowns. So that's why in general we will take plus, and if it is now you get a negative value, then we will understand that is an anti-clockwise moment. Okay, so first equation that is applied is sigma ma is equal to 0, and joint A has got only two members, one beam and one column. So beam moment is already known to you, that you substitute it here and you get column bending moment. So column end moment is positive, which means it is clockwise. And so this is column AH, where you have found a moment value that is clockwise. Okay, so this is this value is 5.1, let us say 09. I have made it as 5.1. So now to find this end moment, which is this is A, this is H. I have just simply wrote that MAH is equal to MHA, means Moment at H also is same. Why I have written like that? Let us see. So there is an axial load reaction, and there will be a horizontal reaction. So all that is possible here. So there will be horizontal reaction, there will be a vertical reaction. Likewise, there will be a moment reaction. So there will be three reactions possible for all these cases. Okay. So now if you apply sigma mh0 for this free body diagram, okay, so that will show you that the end moment is equal to 5.1. Okay, so this is what we are working out here, right? So this, as you know, you have a joint A, there are two members only. That's why you have taken only two moments for joint equilibrium, right? So that is how I have calculated MAH value. Similarly, HA also is being calculated with the free body diagram of AH. Okay, so this is how it is. Then going for joint B, let us see how many members are there at joint B. So joint B has got three members. Now BA, BC, and BG. Okay, the three members. So let us see that expansion BA, BC, BG. Okay, so that is how the equation is expanded. And out of the three values, what you want is BG, column end moment. And the other two values are known. There is 5.1 BA value, 9.876 BC value. Okay, so that are those are substituted. So BG unknown value that is found here. So as I said, from the equilibrium of the member, when you take out from the joint, that will show you the other end is also have same moment. Okay, so that's how it is. Next, joint C. So let us see joint C. So this one. So CB, CD, and CF. So CB, you have a value 9.876. This is the end moment. 10.03 CD value, MCD value. MCF is unknown. So that I need to find out. So MCF is unknown value. Other two values are known, and also directions you already know. So put a negative sign if it is anti-clockwise. So MCF value is calculated. And similarly the other end also, MFC. So this is going to be the next joint D, the last one in the top beam, right? So joint D, DC and DE. So DC and DE is equal to 0. So DC value known to you, DE has to be calculated, that is 10.03. And similarly the other end, ED. So this is how we complete no, the topmost joints. Similarly, all other joints, okay, whatever it is. So when you come here, so As I said, once you complete the solution, you try mention them in your diagram so that it will be easy for you to work out further calculation. So if I now show this 5.1 which is calculated, which is MAH and HA, if I show this calculation, if I take joint H and you see I write the equation MHA plus MHG plus MHI is equal to 0. So where MHA is already known to you. So if you don't draw this, it seems it is not known to you. It is an unknown value, right? So immediately you calculate the value, then you draw it in the diagram. You show it in the diagram. Likewise, all other solutions that you found are meant to be drawn. Then only you will feel that this is the only value that you have to find. This one. This is the only value that is the question mark for you because this is a known value. These values are known to you, right? Similarly, all other columns. So that is how you proceed for further solution. So if you take this joint, there is only one unknown value, and this one is the unknown value because you know this and you know this value. So that is what is written there. So sigma m e, right? Ed, el, and ef. Okay, so joint E and similarly joint H. So all other joints you have to proceed in the same way. There's nothing difficulty, no difficulty involved in this. It's simple addition and subtraction, right? So that's why I'm just leaving all other joints to you to just follow whatever is calculated. Okay, so you see that when you take joint E, you are going to get EL value and LE value, both the ends. Similarly, you take F joint, you are going to get FK and KF value. Similarly, for joint G, you are going to get GJ and JG. Right, HI and IH. So likewise, so you have to get all other joints. There are now you have four joints solved in the first case, then another four joints and another four joints. Okay, total 12 joint equilibrium equations you must perform. Joint I, J, K, L. So that ends the step 4 calculation, which is very easy in calculation. Only you have to understand that the joint moment equilibrium equations are to be written. Okay, then you expand the equation with the members available at that joint, substitute the known value, that means all beam values are known to you, right? So substitute them along with the sign, clockwise positive, anti-clockwise negative. Okay, so that is the step 4 calculation, and let us see the solution part which is drawn after this step 4 calculation. You see 5.1, you can take it 5.1. So this is clockwise, and same here is clockwise. 14.967 clockwise and then clockwise. So all these column end moments are being solved in step 4 and they are drawn in red colored arrows. Okay. Similarly, the other columns, 10.188. So this one, GJ column, FK column, EL column. So all other columns are being solved. You can see when you take joint I, you are going to get IP column. So where The bottom moment is also, that means moment acting on footing, let us say, is also uh, you are able to solve. Don't need to take this joint P where only one member is available. Similarly, all other members. So 12 columns. There are 4 top, 4 middle, 4 bottom columns. So 12 column end moments are being solved. Okay. So if you can see out of all these values, column Kn is having the highest value. It is 53.746. Okay, right? So step 4 to get column end moments is very simple. Just use uh, joint moment equilibrium equations and substitute the end moments of the members joining at that joint. Okay, right, thank you. We'll see further steps in the next session.